In this video, we are going to learn how to sketch curves. Now, we have already sketched graphs previously in National 5 and even before that, when we have sketched straight line graphs and graphs of parabolas. So, a task firstly then, as a bit of revision. What information do you need to sketch the following? So firstly, a straight line. Secondly, a parabola. And thirdly, any curve. So if you pause the video just now and just have a wee think about that. Okay, welcome back folks. So hopefully you had a good think about what information you would need here. So firstly, for the straight line, we could have the Y-intercept, and in order to sketch the straight line graph with the Y-intercept, we would also need the gradient, and we would be able to look at the horizontal and the vertical measures, and that would let us find another point essentially on the graph using the gradient, and that would give us our straight line. Or, possibly slightly easier, we could have any 2 points. So for instance, the 2 in red here, we can join them up but keep the line going to infinity and negative infinity. So that's what we need to sketch the straight line. Now the parabola obviously has slightly different features but a few similarities. So firstly, it's useful to know where the turning point occurs, and I suppose what type of turning point it is, whether it's a minimum turning point or a maximum turning point, and obviously this one is minimum. Secondly, it's useful to know the roots of the parabola, so that is where the graph cuts the x-axis. And finally, like the straight line, it's good to know the y-intercept, and that gives us a more accurate graph when we draw it. Now, we should already know those, but for any curve, it's actually very similar to the parabola. We need turning points firstly, we need roots, and we need the y-intercept. So the parabola in any curve sort of works the same way. It's the 3 same pieces of information we need, but the difference being in National 5, when we found the turning point, was quite a different method to how we find turning points now. So now we use differentiation to find turning points. Obviously we didn't have that knowledge before. So let's go on and have a look at an example on curve sketching. So the example is sketch the graph of y equals 2x cubed minus 3x squared. Now remember what we said before, in order to sketch a curve we need 3 things. We need the turning points and their nature, we need the roots, and we need the y-intercept. So we'll go through each part of this and find each of these 3 things before sketching the curve. So firstly we're going to find the turning points. So we know now, in order to find the turning points, that we need to differentiate the equation of our curve. So we have y equals 2x cubed minus 3x squared. So dy by dx will be 6x squared coming from here minus 6x coming from here. Now again, we know that when stationary points occur, their gradients are 0, and we know that the derivative is the gradient. So stationary points occur when dy by dx is equal to 0, so therefore 6x squared minus 6x must be equal to 0. Now, I can see a common factor here of 6x, so if we use that, we get 6x bracket x minus 1 is equal to 0, and then taking each part of that product there, 6x is equal to 0, and x minus 1 is equal to 0. Now, from the first one, 6x equals 0, we can divide through it by 6, and we still get x being equal to 0. For x minus 1 equals 0, we can add 1 to both sides, and we get x equal to 1. Now, we need to find the y-ordinates of those. So in order to find those y-ordinates, we can take x equals 0 and x equals 1 and substitute back into our original equation, y equals 2x cubed minus 3x squared. And we can see if we put 0 in there, instantly we're going to get 0 out. So the point is 0, 0. And when we put 1 in here, we'll get, well, that'll be 2 times 1, so that's 2 minus 3, which is negative 1. So we have the points 0, 0 and 1, negative 1. And now we need to find the nature of those turning points. It's not enough to just know the turning points. We need to know if they're maximum or minimum or they're points of inflection. So we'll look at each of those stationary points. So we know we have x equals 0 and x equals 1. And for both of those, we know that dy by dx is 0, and we denote the shape there by a small horizontal line to show that the gradient is 0. So on either side of 0 then, so I'll firstly look at negative 1. So when x is negative 1, substituting into dy by dx, well, that gives me a positive. So it actually gives me, what's that, 12? So that's positive 12. And you can see the shape of the graph then, it would be going up, it's rising. Now, after 0, I'm going to look at half. And when I substitute half in here, I'm going to get a negative. So I can see that my shape would be decreasing, it's going downwards. So I can put my wee line there to show that, and you can see here that I've got a maximum turning point then at 0, 0. Now, for when x is equal to 1, on either side of that, I'm going to repeat my half. I can use that again. And then after 1, I'm going to use 2. And when you substitute 2 into dy by dx, that gives you a positive. And again, you can show that that's rising there. So you can see, firstly, that we had a maximum turning point at 0, 0. You can see that shape there. And here we can see, hopefully, that it is a minimum turning point at 1, negative 1. So I'm just going to record this information up here because you'll realise there's not much space left here. So I would pause the video at the moment and take down this information and then come back and we'll complete the information for the roots and the Y-intercept. Okay, welcome back folks. So hopefully you've copied that down. If not, you can rewind and do so. So next we want to find the roots of this equation to enable us to sketch the graph more accurately. So when we're trying to find the roots, remember that is those are the points where the graph cuts the x-axis. And the graph cuts the x-axis when y is equal to 0. So remember the x-axis actually has equation y equals 0. Now, if it cuts the x-axis when y is equal to 0, but I know that y is equal to 2x cubed minus 3x squared. So that must mean that 2x cubed minus 3x squared is equal to 0. Hopefully you can see there's a common factor here of x squared. I'm going to take that out. So x squared times 2x minus 3 is equal to 0. And solving each part of that product, I'm going to get x squared is equal to 0 and 2x minus 3 is 0, which gives me x equals 0 and x equals 3 halves. Now, obviously at the moment I have my x ordinates, I've got 0 and 3 halves. However, instead of substituting back in to the original equation to get my y ordinates here, I actually know my y ordinate already because I got these two values for x because I knew that y was equal to 0. So it then means that the points are 0, 0 and 3 halves 0. And those are my roots. Again folks, I would pause the video and take this information down in your notes. Okay, so hopefully you got that. If not, you can rewind And finally, we're going to look at the Y-intercept. Now the Y-intercept is where the graph cuts the y-axis. So remember, if a curve passes through the y-axis, it means at that specific point x is equal to 0. So it cuts the y-axis when x is 0. And again, that's because the y-axis has a equation, x equals 0. So, if we know that x is 0, we can substitute here into our equation. So 2 times 0 cubed minus 3 times 0 squared, which hopefully you can see gives us 0. So we've got the point, something 0. But again, we already know what x is, because that's how we got our y-ordinate here. So x is equal to 0, giving us the point 0, 0. Again, folks, if you pause the video and take this down in your notes and then come back and we're ready to sketch the graph. Okay folks, welcome back. So, you might notice from the information recorded here, you'll notice that the origin 0, 0 is occurring quite a lot. Sometimes that can happen, other times it doesn't. So it's not really a big deal. Obviously it saves you plotting more points, so just be aware of that. So we'll draw our axis firstly, and we will start by plotting our turning points. So there's 0, 0 and 1, negative 1. And we'll then plot our routes, but you can see that 0, 0 has already been plotted. And we would plot our y-intercept, but again that's already been plotted. Now, for 0, 0, you can see hopefully that it was a maximum. So you possibly saw there with, here, with my mouse, I was going over that there for the maximum, and in 1, negative 1, doing this for the minimum. So hopefully you can now see that that's been plotted. So it's coming up from negative infinity basically. It's got the maximum turning point here. It's then going down to the minimum turning point at 1, negative 1, and it's going back up to positive infinity, cutting through the point 3/2, 0 on the x-axis. And the final thing we need to do, well, we firstly need to make sure we label the points as well. There's key points on there, but we also need to make sure that we label our graph. So in the exam, we generally get a mark for annotating, and that means that we need to write down our coordinate points and we need to label our graph. So I would take this down in your notes and try the assigned exercise.